Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today, we're going to review universal gravitation. This is question number 3. A satellite of mass m is in elliptical orbit around Earth, which has mass me and radius re. The orbit varies from closest approach of A at point A, that's closest, to the furthest at point B, so the distance is B. So we know at A, the velocity is V naught. Assume that gravitational potential energy Ug is 0 when the masses are an infinite distance apart. So express the answers in terms of ABM, ME, RE, V naught, and a constant, gravitational constant, G. A, write appropriate definite integral, including limits, that can be evaluated to show the potential difference of the satellite when it is a distance r from the center of the Earth is given by this Ug equals negative GME m over r. So basically, they are asking to write an integral. You don't have to solve it, just write it. So that comes to really the basic concepts. How do we find the potential energy? Now recall when we learned about potential energy. So we know that gravity, when the gravity does a positive work on objects, such as when object is dropped, when gravity does the positive work, we know its potential energy decreases and vice versa. So we had derived changing potential energy actually equals to negative work done by gravity. When gravity does positive work, potential energy decrease. When gravity does negative work, such as when an object is lifted up, now we know in that case potential energy increase. So potential energy and the work done by gravity is related in such a way that potential energy equals negative work done by gravity, or changing potential energy. So what is gravity? Gravity is GMEm over r squared. We know this is just the magnitude. The direction of gravity is always pointing toward the center of the Earth. Since force is a vector quantity, it does have a direction. So if we use this, work done by gravity is the integral Fg dot dr. Let's see, since we know at infinity it is 0, so we start from infinity, we start from far away and coming toward the center. In that case, Fg and dr are in the same direction. So even though this is dot product, it is just because they are in the same direction, so they are the same. It's just magnitude of one times magnitude of the other. Because they are in the same direction, the angle between the two vectors is 0, so cosine 0 equals to 1. So Fg dot dr is just the magnitude of both. Plug this into Ug. As you can see, this negative and negative canceled. So Ug is just from infinity to r. This is Fg, the magnitude of Fg dr. And this is what they are asking you to do. Use appropriate definite integral. That's it. From here, we can evaluate what Ug is. But you don't have to evaluate now. You just have to write the expression. Take a look at the second one. Determine the total energy of satellite when it is at point A. We know at point A the total energy is the sum of kinetic and potential. So kinetic is just 1/2 mv squared, and the potential energy as given by last question is negative G big M little m over r squared. Substitute appropriate values. You should have E at A, total energy at A is 1/2 mv naught squared. That is kinetic energy at point A plus a negative potential energy at A. Next part, C. What is the magnitude of the angular momentum of a satellite about the center of the Earth when it is at A? So these are all basic concept questions. How is angular momentum defined? Angular momentum is I omega. Remember, for a point charge, for a point mass, it's just mv times r. The mass of the object times velocity times r is the distance from the center of the Earth. Substitute everything in, you should have L at A equals mv naught times the distance A. Next one, determine the velocity of the satellite as it passes point B in its orbit. So again, there is no net torque between the force between Earth and the satellite as the system. There's no outside net torque on the Earth and satellite system, so the angular momentum is conserved. Angular momentum at A equals to angular momentum at B. That gives you, here is angular momentum at A. You can figure out angular momentum at B, then use VB. VB is V naught A divided by B. Next question. Determine the speed of satellite for this circular orbit. Let's see what happens. As the satellite passes A rocket engine on the satellite is fired, so its orbit is changed to circular orbit of radius A about the center of the Earth. What is the speed of this circular orbit? So in a circle, we know when something goes in a circle or changing, gravity is the one provided centripetal force, and in this case, they are the same. We know what gravity is, we know what the centripetal force is, set them equals to each other, and derive your V. Your V is just GME over A. So, next part. Determine the work done by the rocket engine to effect this change. We already learned how the work and the energy related. The work done by the net force always equals to change in kinetic energy. So change in kinetic means after, kinetic energy after minus kinetic energy before. Here is work done equals to change in kinetic energy. We know what V is. We know what V naught is given. So that substitute everything in, this is what you have. That's it for today. Thank you.